Hello everyone. Let's talk about list comprehension. Remember our buddy the list. Square brackets, heterogeneous, indexable, sliceable, duplicate elements, yes, mutable, yes. And even more cool, even more Pythonic is the ability to write expressions that will generate a list after operating over an iterable data type. And this is one of the most Pythonic things you can do, I think. You will see list comprehension expressions throughout code. So it's really important to get a good handle on this and then look for opportunities to apply it and look for opportunities to decipher it when you see it in people's code. The basic syntax, as indicated on the slide, you cobble up what looks like the first line of a for loop, and you preface that with some expression. That expression becomes the populating expression for a brand new list, which is then assigned to the new list variable as a reference. In the previous videos, we touched on this a couple times, but for the most part, we wrote straight out naive, so to speak, for loops and iterated over data structures that way with for loops. But we can also do it with list comprehension. Here's a great example. All I want to do here is duplicate my list, and then we can build on this. So I start out by creating a list called fruits, initialize it to 5 different fruits, and then I build a list comprehension expression that simply iterates over the list. Each time through the loop, the current value in the list is stored in X, and then the basic syntax of this list comprehension says that X will be added to the new list. We're not doing anything to the elements, we're just building a new list from the existing elements. And I'm going to grab that because I'm so excited about it. Go directly back to JupyterLab in my brand new JupyterLab file. Can't wait to run that. Can we rewrite that using the naive approach? Sure. I'll throw that in there. Let's say do the same thing using the, and I don't know if I can spell naive, N-A-I, that can't be right. N-A-I-V-E, hold on. Hey, I was right. Using the naive approach, I can't spell approach. And you'll remember from a previous video that we did find a website that actually did label this as the naive approach. And that's fine. I don't have any issue at all with naive approaches. I think they're often very easy to understand. So what we want to do here is create a new empty list and then drop into a loop. So for x in fruits colon new fruits dot append x and then the print. Okay, the exact same thing using a naive approach. Does it work? Seems to work. Which one do you like better? Do you like the one-line approach or do you like the two-line approach? Well, quantitatively, it's 50% less code, which is silly. But we can build more complex list comprehension expressions, and it's just something that you're going to run into. Python programmers take great pride in their ability to wield list comprehension expressions. And that's great. I think people should have fun programming. Slide 5, here's the same thing that I just did for you in Jupyter Lab. I implemented the naive approach. But in this naive approach, I added a level of complexity. I added an if statement to my loop. And I'm saying here that I only want fish that have the word eel in their name. I have bass, perch, goldfish, pike, walleye, pufferfish, electric eel, and moray eel all in a list of strings. And my for loop that iterates over that list only creates a new list that consists of fish with eel in their name. Okay, you can see then I built on that naive approach. And that's fine. Let's go back to our code in Jupyter Lab and let's just add to this. Let's say we only want fruits that start with P. And I'm going to go into my for loop and I'm going to say only add fruits starting with P to our new list. Okay, I need an if statement. And how do I determine if the first letter of the fruit is a P? Can I index? Well, remember, a string is very similar to a list, so can I say x sub 0 equal P, and then a colon, and then a tab? And that filters out apple. Let's see if that works. That worked. Okay. I've improved on my naive approach by adding an if statement, excuse me, to the loop. And you can see that loop would rapidly get bigger and bigger as we did more processing on that list. Now if I flip back to the slides again, on the next slide, there is that filtering collapsed down into a list comprehension expression. Again, one line of code, and I've tacked on a condition if eel in fish, which is inside that closing square bracket of list comprehension, but following the for statement. So if you compare the naive approach with the list comprehension, they lay out somewhat similarly because the if statement appears to follow the for statement in both circumstances. But I don't need another colon, I don't need to indent, sorry, and it still fits on one line. Let's go back and implement, let's say, implement the P filter in a list comprehension expression. And that's going to be, I'll just copy paste this. I'm starting with this basic list comprehension. I'll throw that down into the new cell. And then beyond the for component, I will say if x sub 0 equal capital P. Give us a print statement to see if it worked. There it is. We've demonstrated that we can do a list comprehension expression equivalent to a for loop. And as we get better at this, we'll build on it and build on it. Back to the slides, number 7. Here's another example. I have a list: happy, sad, dour, bored, scared. Okay, emotions. And the variable is called emotions. How about that? And then my list comprehension says if it's not equal to happy, I want elated. Can you make sense of that? It might help to group this together. So I'm saying give me X if X is not equal to happy, otherwise give me elated. And that's going to filter out the happy and replace it with elated. I still get sad, dour, bored, and scared. I don't get happy anymore, I get elated. Another twist on list comprehension, I would encourage you to take a moment and write that with a traditional naive for loop to accomplish the same result. Another example, I create a string called sentence, and then I define a function. There's my function. The function simply looks at a particular letter that it receives as a parameter, and if it's a vowel, it returns one thing, and if it's not a vowel, it returns something else. So take a look at that, and given that little overview, can you make sense of that function? The first thing it does in the return expression is check to see if it's an alphabetic character, because if it's not, it can't possibly be a consonant. And if it is an alphabetic character, it continues on to see if it's in vowels, which is a string of all the possible vowels. This little 2-line function then tells me whether or not I have a consonant. Pretty neat, huh? Continuing on from there, notice this code is not indented anymore. It's not part of the function. There's my list comprehension. I process all the elements in my sentence string by sending each of them through the isConsonant function. And if it is a consonant, I store it in the new list. If it's not a consonant, it doesn't make the new list. This little piece of code then strips all the vowels out of a given string. So let's grab that and go back to Jupyter Lab, brand new cell, paste, test it. It's ugly. It's poorly written right now. Hopefully you look at that and realize it's kind of a mess because the function is tucked inside other code. So the function really needs to be a little bit more standoffish and separate. It's not very usable right now, except in this context. I couldn't give that to someone else and say, here's a wonderful function to separate vowels from consonants. So what I'm going to do is some chopping. I'll create another cell, and I'll put all the code down into the following cell, but I'm going to take out, if I head back up to the original cell, everything except the function. This is much more elegant. There's my function all by itself in its own cell. And then below that, I'll take out the function. Now I have one cell that I can execute one time. Boom. And now I have a definition for the function stored in the kernel. Then I can execute the code that uses the function and demonstrates list comprehension right there. Okay. That brings us to the end of the slideshow. How about that? Wow. The next thing I would challenge you to do is, if you go back to Canvas again, I have linked to this quiz, Python list comprehension exercises. I think there are about 5 or 6 questions here. And they start out very simple. The first one is create an identical list from the first list. We did that already. And you can type in your code into this interactive input box. You can run it. It provides the solution. Oh, you weren't supposed to see that. You can see the solution, and then that will give you some good practice writing little snippets of code. This is linked in Canvas, so you can find it right there in the learning module where you found this video. Before we adjourn, let's do one more list comprehension that's a little more complicated than we've seen so far. We haven't done a lot with nested data structures, if you will. We haven't done anything with a list of lists. So to get you thinking a little more higher plane, let's do list comprehension with a list of lists, because I want to expose you to building a more complicated data structure. And I'm going to start with just cobbling up my list. So I will say my list equals, and then I'll open up and close a set of square brackets. And simply from that syntax, you know it's a list. At this point, it's an empty list, but you know it's a list. And what we have seen so far is elements separated by commas. This list has 4 elements, 1, 2, 3, and 4. No problem. But let's make this more complicated. Let's say that the first element of this list is also a list. And the second element of this list is also a list. And we'll continue on a little bit farther. And the very last one will make it not like the others. We'll make this one just have one element. Okay, there is a list of lists. As we like to do, let's print it out. Take a close look at it. The whole thing is surrounded by square brackets, and individual elements separated by commas are also lists, which are also surrounded by square brackets. And you could think of this as a two-dimensional array if you like. I just view it as a list of lists. And what I'd like to be able to do then is to filter out the lists that, should I call them sublists? How about that? Would that help? The sublists that are not exactly 4 elements long. And we know there's only one of those. The very last one has only one element in it, -1. But we can write a list comprehension expression to do that. New list equals empty brackets. And I'm going to pause for a moment here, and I would encourage you to take a shot at this, see what you can come up with. All right, let's begin developing the code together. Hopefully you have something you've been able to accomplish. Maybe you've got this to work, maybe you took a shot at it, that's great. And we've been using X, so X for X in my list if len X equal 4. There's my if expression, which will be applied to each element of the outer list. It'll be applied to each sublist. The len function just tells me how many elements are in that sublist, and if there's exactly 4, then that X will be added to the new list that I'm creating. Print that out. Let's see what we get. There we go. We got 1, 2, 3 sublists in our new list created by the list comprehension expression. And we excluded that very last sublist that had only one element in it. And I would also encourage you to convert this to a naive type traditional for loop, just as an exercise. All right, I hope that was helpful, and I will see you next time. Thank you.